Alberto. Next speaker, Alberto Gonzalez Trastoy is from WebRTC Ventures, who, again, we want to thank WebRTC Ventures for sponsoring the event. It was really appreciated. And Alberto will continue this series on artificial intelligence and machine learning, because he will talk a bit about LLMs and how they can be used with Janus. So some interesting use cases that Alberto will present today. Yeah, we can see the slides are fine. So please, Alberto, go on. And do you want to use this mic over here or the handled one? Okay, let me just.
Yeah, quite a challenge to go after you. Okay. Yeah, so I'm thrilled to be here. Like, this is my first JanusCon, and yeah, before we start, I just wanted to share a picture of my wife and I, like, dancing salsa there at the left. Actually, just like salsa dancing, action response interaction is important in what I'm talking about today. So I thought it was somehow relevant. Also, I quite had a plan of a hack. I had a few challenges also, like when I was dancing salsa. So I think there were a lot of similarities. But yeah, we will see how large language models can integrate with WebRTC. And yep, let's go into it. So it started for me watching CES 2024 gadget called Rabbit R1. For those that doesn't know, is basically like a small smartphone that has audio input, touch screen, and yeah, what caught my attention is not the device itself, but actually something they mentioned called large action models. And I was like, wait, what's that? And they showed that they were capable of doing actions with it. So they could schedule a flight, or they could interact with Spotify apps or things like that through voice. So they kind of combine the usage of ChatGPT with actions. Then is when I went into the rabbit hole of finding out what are LLMs. And actually, this is not an academic term, I think. I would say LLMs are more like large language models that perform actions. And what they do is basically work like a standard neural network, just use language. But there is an additional step where you create some symbolic reasoning built into it. So in this specific case, the one I've been working with is creating a relationship between HTML elements and responses from ChatGPT. So it could be like, if basically the LLM understands that a button HTML element is a clickable element. So it kind of works like that. So I will start with first some ideas of when this could be used. So some verticals, use cases that could be interesting for like using large action models. And the most obvious one, or the one that actually was shared in that presentation, was something like get ready for my trip, where you kind of include a combination of actions in different apps. And you can imagine done all that through the browser, but headless browser. So it's search for the email, the calendar, find flight information, and book the ride to the airport. So doing kind of all these actions under through a headless browser, and you are just interacting with your usual device. Another use case could be more like what they call the FAQs in the future. So today you probably have seen it. Some sites start using things similar to ChatGPT in their side to answer FAQ questions. If you are using, for example, Amazon, they have like something called Amazon Q, I think, that just you can ask questions about their services that are answered through an LLM. So the third step, I think, for this could be even going further and doing actually the action that you want to do. So I imagine there isn't anyone here that enjoys, for example, deleting an account of a service that you have been using, you don't need to use anymore, and it's hard to delete the account. That has happened to me, I mean, thousands, many times. So you could just directly through their chatbot say delete my account, and you fill a bit of the information, and that's kind of automated for you. And there are many more here. I just wrote some ideas: scheduling, filing out forms, very repetitive tasks that we don't like to do and that they're pretty structured. So there could be some more related to testing as well. But yeah. So now getting into Janus, and first I will start talking about LLMs because it's more standardized on how to do it, and then move to LLMs and how I did it and failed. So first, you can do that on the client or on the server, obviously. On the client, there is, you can just send it via WebSockets. That's the standard approach. When you do it on the server, and if you are using Janus, there are the three standard, probably most of you already know about how to extract media, audio or video from Janus. RTP forwarding is pretty common. The only issue here is like there is the unidirectional aspect of it. So if you want bidirectional, that yeah, requires more work. If there is also the option of using web, so you could also extract the audio or video that way from the conference. And the one that actually chose, because I wanted bidirectional communication, was to just plug in a WebRTC client, and that could be using GStreamer or could be using Pion, AI, ORTC. So those are just some popular WebRTC clients that can run actually in the server. So once you get that media, you basically, my idea was, okay, you get that media, you want to, if you want real time, probably you don't want to delay the response, and you, like, basically you don't want to type, sorry. So the standard approach with ChatGPT is just type text feedback. In that case, you don't need WebRTC involved at all. But for audio, that I think is a space where it could make a little bit more sense. There is the approach where you just get some feedback in the form of text, which is a little bit less intrusive for the user, or directly the voice. But the voice can be an issue, especially if the accuracy is not 100% there. And this is just like a very, very high simplified flow diagram on like how this is done on the client side for audio to audio feedback. And just you will see that everyone uses WebSockets to send the audio to the speech to text service, and then you use yeah, some LLM service to get the text response, and then you sometimes you could do like the text to speech as we heard today, or just get the text directly. And that's actually how we did it. Yeah, last year was kind of the first year we started to work integrating LLMs into applications. And this is not a real project. I just show like a demo of something similar that I could share. But basically, it's something called Agent Assist. which is a common term in the call center industry, which the idea is that you assist the call, like the agent, in different topics. So in this case, could be a sales agent trying to sell tourist packages, like travel packages, things like that. So you can even go a bit further, and there is something called RAG, which is retrieval augmented generation, where you train the bot in additional context to the, like you give additional context to the bot on the topics. So if it's a company that focus on travel and they have a specific set of services, you already train this bot in advance, so has this additional context, is also listening the conversation, so can provide really useful information to the agents, which many times they don't even know what are the new offers that their company is going to provide. So one question that happens is in that case where you have you are doing the speech to text, you are sending questions to like the LLM service and getting answers, is like when to perform that action. So like you could keep doing it constantly, but that's obviously very expensive. You could let the agent also, of course, do it manually, like say, well, now I need some help, so give me some suggestions. But yeah, the one we have for is like using real-time like topic or question detection. So there's something like, they are like task-specific language models that detect basically the topic that is talked about or the phase where they are in. So let's imagine you are starting a conversation, and when you say like, hello, how are you? Like this is categorized as an introductional phase, and that is tracked. So you get the detection of, okay, this is an introduction. And with that context, the bot can respond. Then you go to maybe another phase, which is sales phase. And in that phase, there is an additional context that you want to provide to the bot. So using this kind of tracking technique, you can, yeah, be a bit more useful in the for the agent. And other considerations here, on the client side, I think it's okay, like you just send the audio via WebSockets, but it's an issue if you have many participants and you want all the participants to be able to communicate with the same bot. No? But then in that case, if you run things on the server side, you will have to, you will have additional latency, because it's going first to the server, then to the speech to text service and the LLM. So it just becomes in real-time scenarios a bit too much. So that's why here I mentioned that the ideal scenario would be to have all these services co-located. This is that it's not trivial for everyone to like have like a an LLM API running on your own. Other issues that happen if you want to integrate WebRTC with LLMs is that most of them are trained for PCM audio format. So you just, or you use PCM in a WebRTC call, which that can be done with Janus. But as we know, like Opus is kind of more standardized for WebRTC, so you might need to do transcoding there well, to actually use all these models. So I talk a bit about like the large language model interaction. Now, how we do that with large action models, how we perform actions, no? And well, I based this demo on using some data set called Mind2Web. It's a data set that just perform like a lot of recordings of different operations on popular websites. So that's the list of the different like type of websites they store information about. Basically, you use that to know how to do operations on websites like search, select a date, these kind of very common tasks. Then, in addition to that, I also had to use some computer vision large language model. So just something that allows me to get information from the screen we are in and match it to and give that information then later for perform action. I will talk about more in the next slide. And then the headless browser to perform the action, and something that puts all these things together, which is based on an open source project called CACT, which is like a generalist web agent that carries out the browser tasks. And yeah, you have the links there. I will be sharing that later. So in more detail, the steps that you probably care about or that are more important are these 7 steps. So it's action definition. So first, let's say you are in a call and you are talking about you want to perform a specific action, like search for the status of my flight. So that would be the action definition, point 1, and you would do like this speech to text. Then once you have that action defined, then in my case I use Playwright. You could use any other headless browser tool, but you just start that and gather all the HTML elements from the list. I use a cross encoder to compare the top candidates. A cross encoder is basically like a comparison between similarities of words. So it was kind of would say, like, if I want to I want to search for something, it's going to find the HTML elements that are related to doing that, performing that task. Then there is the capture of the screenshot, and I do the 2 steps of inference. First one, to gather information of the screenshot, so where we are right now. Like I see the Google Chrome UI, and there is a search bar with a button that says search next to it. And the next step, once we have that information and we have the list of HTML elements, I send all that in the point 6.2 is say, okay, now what I should do next if my goal is this. And in this example would be like, if I'm searching for ABC, the next step probably is click the search bar, and then you keep doing that recurrently. So it performs like a lot of tasks for subtasks for every task. And this is kind of the flow diagram of that whole thing. So you have the user is connected to Janus. I'm using a WebRTC client. In my case, I use AIORTC, which is Python based. So I just thought, well, AI is related, so let's use that one. Keep doing audio to text when the user is speaking. And I kind of use like a hot word, kind of like how the Alexa or Google Home work, just detecting when I say the word bot, it just triggers the action. So I would say bot, search for a blog post about this specific topic. Then what it would do is use that, spin up the headless browser that we see there. And once that's open, we start capturing the image. We send it in the first request to the third-party large language model. And then we get feedback, like the information from that image. And then we perform the second request on matching the operation to the specific HTML element. And this is this kind of same, more specific on what I use, like the Janus, a Python WebRTC client. I wanted to use Whisper on the server, so I kind of run it in the same place. and also CACT, which is like that logic I said that matches HTML actions with responses from ChatGPT. And here is just like the tech stack. You can take a quick look of like the different things I used for this. I would have liked to do the multimodal GPT for V in an open source, but there wasn't anything that was accurate enough, at least that I could set up quickly. But yeah, this is just a quick demo, spin up. So I will talk about the issues of this, but yeah, basically, well, this is a Janus video room, and I already started transcribing, so it's doing speech to text, and well, the one issue that I'm having is that, well, I'm running this demo everything on my laptop, so the transcription needs like it's quite poor, I would say, like it wasn't very accurate, but luckily picked up correctly my action. And yeah, once I say the word bot, then this spins up and I'm just showing this here, but this would be done on the server. The user wouldn't even know that this is happening like this, but it just spin up the headless browser, and now it's doing the request to perform the next action. So what just happened is not noticeable, but we just click flight status. I just asked for the status of A112, I think, and just click there. And the next step is to click on the date, I think, or the from. It just doesn't follow a standard pattern, so it will change based on how the request is. Yeah. But yeah, it right now it doesn't have like an end. So what happens is basically that once it reaches the operation that was requested, it just like finalizes the operation as I just stopped. So obviously this is a pure hack. It's not like anything that could be used in production, but it's just something that I think I wanted to share to bring this to everyone's attention, that is something that perhaps in a couple of years could be doable at the speed that we are moving actually. And right now I want to talk about the huge challenges I had with this, and also why it was recorded and not demo live right now. So one is risk. This is crazy. The transcription can be done in sub-second latencies, so speech to text is not a big deal. Obviously, WebRTC is sending media to the WebRTC bot. That's the bot is co-located, is next to the server, so that's just picking up that audio right away. What is a big issue is that you are doing the LLM prompting, and in some situations when it's just a request, it's okay because you can get the stream back and you can start seeing the feedback. But in my case, I had to do 2 prompts. So waiting for the first one to complete and execute the second one. And that's the issue where like I couldn't really come up with a quick solution for that. So you wait for the response based on the image, and then you execute the other prompt to perform the action. And yeah, it ends up being, and this is just would be if you wanted to do a very simple operation of the browser. If we're talking about like 10 steps where you are searching, it can be minutes to do that. So yeah, as I said, like the main bottleneck is the multiple prompts that needs to be done, and I actually am forced to wait to the first one to complete. Some potential improvements that can be done there I can reduce the size of the response. So there are like I can limit that. I can prompt requesting shorter responses. I can also use some initial context already there. So I could have the bot with context in advance. So if I know this is going to be for a specific website, this obviously simplifies things a lot because then I know for example, this is going to be for IETF website. So I push that in advance, and when I perform actions later, um, it's not as slow. Maybe I could skip even one of the requests. And caching, of course. So this is just because I'm doing the operation for the first time. But if like another user already wanted to search for the status of that flight, it's obviously something that can be given like right away. The other issue was CPU, and this is because I insisted on using speech to text on a CPU-based server. So didn't. I wanted to test it out and see if like I can run it on just some CPU server, and it's crazy actually. And I thought it was interesting to see that for a single transcription, I was using 100% of the CPU on a X large AWS server. So obviously that doesn't scale very well. This is obviously not how people do it, and they would use a GPU, NVIDIA-based server, and so on. But was just interesting to see compare with how much Janus uses for 3 participants, which was in the range of like 3% or something like that. And the other one is obviously cost. Transcription, that's not the most expensive, but yeah, there is some cost there, and particularly the like the amount of HTML elements that I had to send to the LLM was quite huge. So you could imagine that this makes sense maybe in some situations, but if it's checking the flight status, I don't know, maybe for some people might think that they can check it instead of spend like 5 cents per, like 50 cents, sorry, or 30 cents to get that. But yeah, so obviously the latency I think is the biggest deal, but I think this is also a challenge. So on the next steps, well, one obviously is doing the speech to text the right way, and run it on a GPU-based server. The other one is to display the browser actions in real time. So it's just not, instead of having like that, I was, probably you didn't notice, but at the bottom, I was just using data channels to get the responses from like the bot, and the bot was giving like kind of outputting everything via the data channels. But yeah, would be better to see that feedback happen in real time on the video call, and you maybe could combine that with the data channels feedback to redirect the bot. Because what happens with this is that the accuracy is around 60 to 70% based on the research paper from CACT. So that obviously is a big issue, and you need feedback for this kind of stuff. On the long term, one improvement could be applying partial results to the query. Also, something that is not available yet, but would be nice to have stateful prompts, so I don't need to keep sending what I previously sent in my last request. So that would be a huge cost improvement. And the other is to use the self-hosted LLM servers. One is Lava, which supports vision. There aren't that many that support vision right now, so that's also something to look forward to. And Yep, I think this is kind of like the conclusion. We have WebRTC is well suited to provide real-time feedback. So I think so many of these operations can be done synchronously, but they still need some user input to guide it. So that could be where WebRTC plays has a role there. The other one is that, yeah, definitely large section models in RTC are not doable. It's a multi-step process that makes it unusable. And one other thing is that we are seeing RTC and large language model integrations actually in production already, which is exciting. And we are seeing it more now implemented internally by companies. It's not something that is as much exposed to users, at least in the real-time communications field. But yeah, looking forward to it. And thank you so much. And yep, a pleasure to be here.
Thank you, Alberto. Any questions for Alberto?
How much simpler would the process be if we would not use, for example, a browser to drive all those actions, but have, let's say, a scope of a limited API? Let's say I'm American Airlines and I have an API for that, and I want my model interact with that.
Yeah, I think that definitely would be the way to go if you want to use it now. Like you wouldn't need the additional context of which website you are using, or now I'm getting a screenshot every time to know even how the website looks like, because there is a lot of variance. But if you know the format, you could have this performance. Still, I think it's very slow because every task, so imagine you want to search for the status. You first click this button, you then type the date where it lives and so on. So that's, yeah, I think it's not doable. But if you have access to the American Airlines API, for example, in that case, yeah, the issue is that many don't expose this kind of information, and how they expose it is actually through the browser. So yeah, if it's exposed, definitely the way to go is just work with that, and then you will be able to get real-time like feedback. And that's actually what we did in a project where we just added the context in advance, and we knew what they are selling. We knew what the information the agent needs to know. And then in that case, yes, it's doable, and you get the responses in, I would say, typically we achieved between 1 to 2 seconds for first character response, since you were talking and then you activate it, and then it takes about 2 seconds to get that first character appear at the bottom.
Questions? Okay, thank you. Thank you, Alberto.